Welcome to the distance learning program presented by Innobus on design patterns. What is design pattern? Design patterns provide architectural solutions to common recurring software design problems. So these are the solutions for architecture where the problems will be recurring, and the recurring problems, the software design solutions are called design patterns. These patterns have emerged over time through the experience and insights of developers. Why to use design pattern? They are proven. It means patterns reflect the experience, knowledge, and insights of developers who have successfully used these patterns in their own work. They are reusable. Patterns provide a ready-made solution that can be adapted to different problems as necessary. They are expressive. Patterns provide a common vocabulary of solutions that can express large solutions. They help you to communicate your idea. Therefore, design patterns prove particularly useful in building the application architectural layer. An application layer that effectively design patterns can be used. So they offer organizations high quality, flexible applications that stay within budget and timeliness. Let's see three-tier distributed architecture for any kind of enterprise application. So this is the basic three-tier distributed architecture which can be found in any of the enterprise application. So these components you can see in Java Enterprise Edition, where these components are divided into presentation tier, business tier, and integration tier. So within the presentation tier, you can get your browser involved in it, having HTML, applet, JSP, or any Java desktop application. Within the server side, you can also involve JSP, which in turn is it in presentation tier, it also runs within your server. So therefore, JSP, Java Servlet, these are also coming under presentation tier. And in business tier, you have EJBs, nothing but enterprise Java beans. And finally, in integration layer, you'll have the databases. So this is the basic three-tier distributed architecture used in any enterprise web application used by Java Enterprise Editions. So now we are going to talk about Java Enterprise Edition design patterns, which are used for designing your enterprise application, and these design patterns will be applied on all the J2EE, that is Java EE, Java Enterprise Edition components, just now what we saw in our previous slide, the architecture, all the components. So these design patterns will be applied on them. So what are JEE design patterns? These are collection of Java Enterprise Edition based solutions to common problems. They identify potential problems encountered when using the various Java Enterprise Edition technologies. In JEE projects, combine patterns with sound real-world experience to construct application architecture. With this approach, your application architecture will not only be robust, scalable, and flexible, but also reusable across many future projects. So that is the importance of any design pattern. You can reuse them. So most appropriate use of design pattern. This is the most appropriate way you can reuse your design patterns. And these are the popular Java Enterprise Edition design patterns. So as we have seen the three-tier architecture in our previous slides, and these are the design patterns which are applied for each of the tier. that is presentation tier, business tier, and integration tier. In all these tiers, you have these design patterns to be applied on. So we are going to talk some of these design patterns in our course which we are discussing on Java Enterprise Edition design patterns. So if you look into, you have in presentation tier, intercepting filter, front controller, context object, application controller, view helper, composite view, service to worker, dispatcher view. These are all applied on presentation components. And for business tier, you have design patterns like business delegate, service locator, session facade, application service, business object, composite entity, transfer object to assembler, that is transfer object assembler, value list handler. And for integration layer, you have data access object, service activator, domain store, web service broker. So we will be discussing some of these design patterns. Model View Controller Design Pattern, which is famous as MVC design pattern. So the name of this design pattern is Model View Controller. Context, where does this problem occur? So MVC is an architectural pattern that is used when developing interactive applications such as shopping cart on the internet. The problem is user interfaces change often, especially on the internet where look and feel is competitive. So any internet application, you need to be careful in look and feel to make it more attractive. So here the same information is presented in different ways. The core business logic and data is stable. So this is some kind of problem which you can face by developing any enterprise application. So let's see the solution by using model view controller design pattern. And the solution is use the software engineering principle which says separation of concerns to divide the application into three areas. That's where this model view controller design pattern came into solution for developing enterprise application. So model, which will encapsulate the core data and functionality. View encapsulates the presentation of the data. There can be many views of the common data. And controller accepts input from the user and makes request from the model for the data to produce a new view. So these are the solution which come upon as model view controller design pattern. For example, this is used in struts and Spring MVC framework and many more. So this is the basic diagram which clearly shows you the separation of model component, view component and controller component in MVC controller design pattern. You can see controller only handles the request and invokes appropriate model. Within the model, you will have controller commands which will be acting as your business logic for acting the request upon. So once you have those actions, you will perform either retrieving the data through entities or any other business logic. And this is all under model, which is completely separated from your controller as well as view. And finally, when you get the response back, it will come through the view, which is responsible for JSP template response engine, which goes through the view formation, and finally through the controller you will get back your view by selecting appropriate view. And this is how the model view controller helps in separating the presentation, the controller model, the controller, and finally the business logic. Let's see front controller design pattern. So here, suppose you come across a problem for any development of your enterprise application where the problem will state that you want the centralized access for presentation tier request. So basically what will happen in the problem here is, the problem will be each user will have his own HTTP message for specific view. So this will lead into number of requests handling number of views. So one to one, which will be a major task for any application. So this will be a problem. So let's see the solution. Before seeing the solution, we'll also see the scenarios where you actually want your friend controller design pattern. In what scenarios you need this design pattern to be applied. So these are the scenarios like you want to avoid duplicate control logic. Apart from the design pattern, you also want to avoid the duplicate control logic. You want to apply common logic to multiple requests. This is what is the requirement. You want to separate system processing logic from the view. You want to centralize controlled access points into your system. And finally, for all those scenarios, you have the solution, and that is a front controller design pattern which provides a single entry point through which all the requests for several resources in a web application pass. So if you see in this diagram, before the user request had one-to-one mapping with the view, but here you have user request HTTP message passing through the front controller, in turn which will access respective view. So in turn direct communication, there is a front controller which is coming into picture for accepting the user request and then delegating the request to respective view. These front controllers are very much useful in controlling page flow and navigation, accessing and managing model data, handling business processing, accessing relevant data to GUI presentation, for example, user profile, and many more. So this is the example. In Struts 1.x onwards, there was a front controller which was used, which normally was a servlet, that was action servlet, and this action servlet, which was defined in web.xml configuration, that is descriptor file, was acting as a controller to receive all the requests and then direct it to appropriate action or view. So this was the controller for Struts 1.x version. And in Spring framework, there is a dispatcher servlet which will act as a front controller. So this is the definition which you define in deployment descriptor, and dispatcher servlet will receive all the HTTP requests and then act as a front controller to delegate it to appropriate action or view and get it back from the result as a response to the end user. So these are the example for front controllers. Let's see the benefits of it. So the main benefit is it will centralize the control of the logic. The front controller itself will try to get all the user requests and then delegate for appropriate view. So improves reusability, improves separation of concern. When to use this design pattern? You have to use front controller design pattern to apply common logic for multiple requests. In that scenario, you have to use this front controller design pattern. And finally, separating the processing logic from the view. Next is intercepting filter design pattern. So here you can see filter where we generally come across in design pattern. So let's see intercepting filter design pattern. The problem where any developer can face in developing enterprise application can be pre-processing and post-processing of a client web request, and responses are required. So whenever a request enters a web application, it often must pass several entrance tests prior to main processing stage. For example, Has the client been authorized or authenticated? Does the client have a valid session? Is the client's IP address from a trusted network? Does the request path violate any constraints? What encoding does the client use to send the data? Do we support the browser type of the client? So these are the certain questions which will be answered or should be answered by any enterprise application. So these are the initial steps before accessing or processing your request. So these should be verified before performing any kind of business logic. For that, let's see the scenarios where you come across, like you want centralized common processing across requests, such as checking the data encoding scheme for each request, logging information about each request, or compressing an outgoing response. You want pre and post processing components independent of each other and self-contained to facilitate reuse. So these are the scenarios which you want to get the solution for, and this is the solution where you can use intercepting filter design pattern. So what happens here is you have to create pluggable filters to process common services in a standard manner without requiring changes to core request processing code. So therefore, the filters intercept incoming requests and outgoing responses, allowing pre-processing and post-processing. So here if you see in the diagram, you can see the filter like debugging, authentication filter, or any kind of filters can be plugged into before actual processing of your request and after controller directing to your filters. And this is how it works. So file manager, here the file manager manages filter processing. It creates the filter chain with appropriate filters. So in the correct order, and also it instantiates the processing. The filter chain is always ordered collection of independent filters. You have filter 1, filter 2, filter 3. So these are all individual filters that are mapped to a target. So therefore, target is the resource requested by the client. So before reaching the target, you need to perform all these filter operation on your request, on the client request. So for all those requests to be filtered, you can easily plug in these filter components which will hold authentication or any kind of debugging filter or any kind of networking information. So you can have these filters in handy for any kind of enterprise application. So these are the examples. If you have worked in struts too, we have something called struts prepare and execute filter, which is very useful in passing through all the interceptors, and this filter plays an entry point. And in servlets, you do have a filter which can be got using extending generic filter class, and it also has a filter chain which can be passed among several filters. So this is a small snippet which you can see there is an authorization done. So here if you see there is an authorization which can be taken place if an user is authorized or not. If he is not authorized, it will be shown a message he is not authorized. So these are the filters of simple filters which can be used in your frameworks, in your servlets, in your struts, and many more. So let's see the benefits of it. Centralizes pre-processing of request, centralizes post-processing of request, improved reusability, increased flexibility, and when to use. You need to pre-process a request or a response, and you need to even post-process a request or a response. So in those scenarios, you need to use this intercepting filter design pattern. Next is composite view design pattern. So suppose if you have a problem like you want to build a view from modular atomic component parts that are combined to create a composite whole. So while managing the content and layout independently. So for this problem, you have some scenarios also to be seen. What you want, like you want common subviews such as headers, footers, tables reused in multiple views, which may appear in different locations within each page layout. So this is very generic. It is something like a template for your any view page. So you have content in subviews which might frequently change or might be subject to certain access controls, such as limiting access to users in certain roles. So even using the view, you can limit the access for the users. So based on the user role or permission, you can also limit the view what he can see. The end user can be limited. You can just see what is role all about. If he is an admin, you'll see the role of giving access. If he is an end user, you won't be able to see the admin page. So all these will play an important role when you design any kind of composite view application. You want to avoid directly embedding and duplicating subviews in multiple views, which makes layout changes difficult to manage and maintain. So these are the scenarios where you require design pattern to be applied in these fashion. So finally, the solution is composite view design pattern that are composed of multiple atomic subviews. So each subview of the overall template can be included dynamically in the whole, and layout of the page can be managed independently of the content. So if you see, this is a typical example in any of the JSP or HTML or any kind of the view page you come across in any application or internet application, you will see the segregation of header, footer, navigation, and the main JSP. So here the single JSP is made up of the template JSP, which always comes in a header part which act as a banner, and also there's the sidebar which is navigation, and there is a footer JSP. So JSP made up of different JSPs will give you a composite view. So this gives you a separation of views. You can also reuse for each and every page of your application, and these views can header and footer may not change in your application, and you can keep this template as it is. So this is the advantage of your composite view, and this comes through your composite view design pattern. And if you see the snippet here, this is the basic JSP snippet where you can give the key as banner and the value you can locate for respective JSP. So one screen is composed of many JSPs, and this is what is composite view design pattern. So let's see the benefits. Code duplication is reduced because you can create common headers, footers, and other components. So you need not uh, code again and again for all these components. You just have a template and apply the same header footer for each page. So there will be reduction or avoiding of your code duplication. Views can be changed based on access authorization. So as I have said earlier, based on your access for particular user, the pages can or the screen can be shown upon. Some components can be completely hidden. If he doesn't want to see the navigation view, you can completely hide that navigation view by separating all these pages within a screen. By composite view design pattern, you can achieve by giving an appropriate separation of your views. When to use this pattern? So you want common view components, and you want view component with changes based on authorization. So this is the block diagram of composite view assembly. So here if you see, there is a client which is having a request and which is passing through the front controller. We have already discussed front controller design pattern. It will take the request and it will forward the HTTP request to appropriate servlet. And finally, the servlet will uses the JSP page, which will be composed of many templates. Next is business delegate design pattern, which will come under business tier of application or architecture. So suppose you have a problem. You want to hide clients from the complexity of remote communications with business service components. So then you have scenarios to be met, like you want to access the business tier components from your presentation tier components and clients such as devices, web devices or services and rich clients. So you want to minimize coupling between the clients and the business services, thus hiding the underlying implementation details of the service such as lookup and access. You want to avoid unnecessary invocation of remote services. You want to translate network exceptions into an application or user exceptions. You want to hide the details of service creation, reconfiguration, and invocation retires from the clients. So these are the scenarios when you come across any business, enterprise, or complex application what we have in daily scenarios. But in all those applications, it is necessary to meet these scenarios. So in order to meet these scenarios, let's see the solution. And the solution will be your business delegate design pattern, where you use a business delegate to encapsulate access to a business service. The business delegate hides the implementation details of the business service, such as lookup and access mechanism. Suppose if you see this diagram, what happens here is whenever the client will continue with this request, then the client here can be after your front controller, the request coming from, and the business delegate will directly have the point towards business service. It will not hold any kind of implementation of your business logic. It will just have a delegation for business service. So here you just have an access for business service which is performed by business delegate, and directly it can communicate to business service using lookup service. Therefore, by hiding all the implementations done by business service. So any client should go through business delegate, which will just have connections to your business service, which will in turn hold your actual implementation. So by getting your business delegate in between, you are communicating indirectly to your business service. And this is usefulness of your business delegate design pattern. So let's see the benefits. It reduces the coupling, improves maintainability, translates business service exceptions, improves availability, exposes a simpler uniform interface to the business stack. So as said earlier, business delegate will be an interface. So therefore, any client coming to your business logic, it has to go through this interface which in turn it will communicate through your business service, which will give your implementation of your business logic. Improves performance. And when to use this business delegate design pattern? When you want to encapsulate access to business services from multiple client types. Translate exceptions into application exceptions. So here also there is a major advantage where you can get the applications and then translate into appropriate application exceptions through business delegate. Hide details of service creation. Next is service locator design pattern. This is also one of the design pattern applied for your business tier of architecture, that is JEE architecture. So here, suppose if an user has a problem, that is developer has a problem where he wants to transparently locate businesses components and services in a uniform manner. So this is example of JNDI, which will look up EJBs or JMS. So JNDI is also Java Naming Directory Interface, is also a huge uh, concept which will does the lookup for all these EJB client, JMS client, web service client, and many more. So here you want something to be transparently locating the business components and services which will be in a uniform manner. So in order to get the solution, let's see what are the scenarios you want to meet with the solution. You want to use the JNDI API to look up and use business components such as enterprise beans and JMS components and services such as data sources for database connection, web services, LDAP, and many more. You want to centralize and reuse the implementation of lookup mechanism for J2EE application clients. So you want to encapsulate the vendor dependency for registry implementation and hide the dependency and complexity from the clients. You want to avoid performance overhead related to initial context creation and service lookups. This is how you get an access by using initial context and service lookup. So you want to also avoid the performance overhead by doing this lookups. So for all these to meet, there is a design pattern that is nothing but your service locator. It is also one more scenario to be met. You want to re-establish a connection to previously accessed enterprise bean instance using its handle object. So this is also useful in pulling the objects and unnecessary creation of objects. So let's see the solution, which is nothing but your service locator. So use service locator to implement and encapsulate service and component lookup. So here you have a service locator which will hide the implementation details of your lookup mechanism and encapsulates related dependencies. So here service locator will be an interface or interface class which will give you just a brief of your invocation to JNDI, and it will be a great lookup for your JNDI by hiding the actual implementation of your JNDI. So this is how service lookup or locator will be useful in the enterprise application, especially using Java enterprise application. And here if you see the diagram, you have a client which is using service locator, and in turn service locator will use initial context which does a lookup on service factory, which finally gives you the business service by getting the service back. So this is how service locator will be interface for your lookups. Benefits: standardized approach to retrieving business components, abstract complexity, provides uniform service access to clients, facilitates adding EJB business components, improves network performance, improves client performance by caching. And when to use the service locator design pattern? You have many different business services that are located in different ways. Session facade design pattern. So the problem can be enterprise bean encapsulates business logic and business data and also expose their interfaces, and thus the complexity of the distributed services to the client tier. So therefore, you want to expose business components and services to remote clients. If that is the problem, let's see the scenarios which you want to meet. You want to avoid giving clients direct access to business tier components and also to prevent tight coupling with the components. So therefore, you have to avoid direct access as well as avoid tight coupling between the clients. So you want to provide a remote access layer to your business objects and other business tier components. You want to hide the complex interactions and interdependency business between business components and services to improve manageability, centralize logic, increase flexibility, and improve ability to cope with changes. So these scenarios should be kept in mind to consider proper design pattern. So let's see the solution of it. Solution is use facade, that is session facade design pattern to encapsulate business tire components and expose a coarse-grained service to the remote client. So clients access a session facade instead of accessing business components directly. So here, so coarse grain means that will be hidden. Coarse grain will always be the outer layer of your business. It will not be the actual implementation. That's how it is telling. So you expose this coarse grain service to remote client and not the actual implementation. So therefore, by using this session facade, you can directly avoid the client interacting with your business components. And also you can avoid the tight coupling between the client and business component. So session facade will be an important role in this design pattern. Benefits: introduce a layer that provides services to remote clients, exposes a uniform coarse grain interface, reduces coupling between the tires, promotes layering, increases flexibility and maintainability, reduces complexity, improves performance and reduces fine grained remote. So fine grained, it means the deep or the actual implementation of your business logic. Centralizes security management, centralizes transaction control, and exposes fewer remote interfaces to the client. So when to use this session facade design pattern? You should use the session facade design pattern when you have a series of calls to make to business components from the client. Next is the transfer object design patterns. So if you have a problem where you want to transfer multiple data elements over a tire or a network. So here if you see, you have details like name, city, state, and all these details have to be transferred over multiple networks. So here what happens? So every time there will be individual data going. There will be name separate, city and state. So information are in bitwise. So there will be multiple datas over the network. So this will be a network traffic, congestion and also a data breakdown. So for this problem, let's see the scenarios which should be meeting the solution. You want clients to access components in other tiers to retrieve and update data. You want to reduce remote access or request across the network. You want to avoid network performance degradation caused by chattier applications that have high network traffic. And the solution for it? Use a transfer object to carry multiple data elements across a tier. So therefore here if you use a transfer object, you can easily bind all those data to this object and send this object alone. So therefore instead of sending multiple data elements one by one at a over a client, over a network to a client, what you can do is you can put in one single object, all the elements you can put in a single object and then pass that object over the network to your client. So here to speak more about it, you have an object which is nothing but a Java class which will have your getter and setter methods, and it will just implement serializable for transferring the data over network, and therefore that object will have all your data, for example name, city, state for particular client. So within that object you can set all those data and send that individual single object over the network instead of multiple data. So this is the solution where the transfer object design pattern will be useful, and it is also very useful in any kind of complex enterprise JEE applications. So here in diagram, if you see, there is a client which is wanting to access transfer object, which finally have a component through which the transfer object will hold or uses the object having all the values in it. The benefits: reduces network traffic. Therefore, instead of multiple data, you can have only one single object holding that multiple data and getting transferred over the network. By reducing network traffic, simplifies remote object and remote interface, transfers more data in fewer remote calls. When to use this transfer object design pattern? You need to send objects between tiers, that is presentation tier, business tier, and integration tier. Transfer objects are mainly used between integration tier and business tier. Data access object design pattern. So if you have a problem where you want to encapsulate data access and manipulation in a separate layer. So therefore, here if you consider, there is a single control class which is having data access code. So here, instead of having a single control class which involves even the data access code for the database, you want to separate it. So the problem is you have everything in a single class. The class which is having controlling of your business logic, as well as it is trying to access the database which will have database code, and that is the problem. Solution will be to separate these two data, that is one having control class and one having data access object, which in turn connects your database. So let's see the scenarios which you want to meet up using design pattern. You want to implement data access mechanisms to access and manipulate data in a persistent storage. You want to decouple the persistent storage implementation from the rest of your application. You want to provide a uniform data access API for a persistent mechanism to various types of data sources such as Relational Database Management System, LDAP, Lightweight Data Access Protocol, WODB, that is Object Oriented Database, XML, repositories, flat files, and many more. You want to organize data access logic and encapsulate proprietary features to facilitate maintainability and portability. So to meet these scenarios, the solution will be use data access object to abstract and encapsulate all the access to the persistent store, which is nothing but your database. So you can use a database object as a class, which in turn can interact with your database instead of mixing that with business logic class. So therefore, the data access object manages the connection with the data source to obtain and store data. And here if you see in a diagram, the client can use the database, that is access object, which can hold like operations of this database like create, read, update, delete, and all these are operations to be performed using database. So within this class, you can access the data source, which in turn can access the database to get your data. And also if you notice, there is a transfer object. So here data access object class can use this transfer object, which in turn will have details of data to be performed. For example, you want to read or update or delete. So from client, you will get the transfer object, which will in turn hold the properties of name, city, or any feature of your class of customer, for example, and that particular transfer object, Java class instance, will be used by the data access object class to perform database operations. And this is the data access object design pattern, where you can see where the data access object come into picture. Here if you see, there are three tiers: presentation tier, business tier, integration tier. And within the integration tier, you have the classes which are nothing but your data access object classes, dealing with all the operation as well as connections to your database. Data access object design pattern benefits: abstracts data retrieval from data source, enables transparency and easier migration. So you can easily migrate from any of the database. You can migrate from Oracle to MySQL or any kind of database, SQL Server. So migration is easier when you use this data access objects. Provides clean separation of business and data logic. This is what is the main advantage, where you can separate the business logic and the data logic. So you can have two classes, one class dealing with your business and other class dealing with the data logic, doing connections and then getting the results back, handling the connection and many more. Reduces code complexity in clients, organizes all data access code into a separate layer. And when to use data access object design pattern? Decouple data access from the business logic. This is the main reason where you have to use data access object. Provide all data accesses from in a separate layer. Data access object factories design pattern. It means that there is a class which can give you the data access object instances of many different data access objects. So you can have more than one data access object. So in previous slide we had seen in integration layer there were many DAO, which we call as data access objects. So all these object instances you can be got using this factories. So there is a data access object pattern which can be made highly flexible by adopting the abstract factory. So this is one of the design pattern of Django 4 and the factory method. So these two factory methods and abstract factory can be used for adopting flexible data access object design pattern. When application use a single type of persistent store and there is no reason to change underlying storage from one implementation to another, data access object factory strategy can be used to provide a variety of data access objects. Extend the flexibility of the factory implementation by using the abstract factory pattern. This could happen if the persistent stores change frequently. Persistent store, it means the databases. If you want to change the databases every time based on your requirement for your application already developed, if you have developed with Oracle and you want to change it for SQL Server or any other database, then you can use this design pattern. So here if you see, this is how the data access object factory will work along with abstract factory and factory pattern of Django 4 factories. And here if you see, within a factory class you can have many data access objects being provided. So therefore you have employee DAO, that is employee database object, and department data access object and many other objects. So all these data access objects can be given in a single class in abstract way, which includes the abstract factory as well as factory method. And this is all about data access object factory design pattern. Here we come to the end of this training on design pattern. Basically, we spoke about Java Enterprise Edition design patterns, and some of the design patterns we also said and read in detail. So this was the end of the training. Thank you.